I believe that's the problem with the pipe in the corner of the attic. I want to do that one together in class, so you can just skip that one for now. And then if I forget, remind me on Monday if we have time after the quizzes, or on Tuesday during class, and I'll make sure I do that one because I know that that's one that there are questions on every year. And there will not be anything like that one on the quiz. Okay, so for number 44, we're looking for, or we want to show that the equation of a line with an x-intercept. So the way that this is written here, it means that the x-intercept is a, and it's specifying that a is not 0, and then the y-intercept is b, which is not 0. So it's kind of combining two statements together when they say x-intercept a not equal to 0. That just means whatever the x-intercept is, it's not at 0. If the x and y intercepts were both 0, then we would be passing through the origin with the line, and we can have the equation of a line that passes through the origin, but if that is just the x and y intercepts, then that's not enough information to write the equation of a line because it's only one point. Like I could write this line or this line or this line, and we don't have enough information. So that's why they're specifying. Also because we have division by 0 if a and b were equal to 0. So don't get thrown off by that. This is just saying we have an x-intercept for some generic point A and a y-intercept at some generic value of B, and we want to show that we can write the equation of the line that passes between those two in this form. So I'm going to start with writing 2 points because we either need a slope and a point or 2 points equation of a line. So we'll write the intercepts as ordered pairs, use those 2 points to find the slope, and then once we have the equation of the line using the slope and one of the points, we're going to algebraically rearrange it to show that it's the same as this. Okay? So x-intercept is the place where we cross the x-axis. Any point on the x-axis has a y-coordinate of 0. So I know that the point A0 is going to be on my y-intercept at B at any point on the y-axis has an x-coordinate of 0. So that means that we have a point at 0. So these, for some values of A and B, are the 2 points that are on the line connecting those intercepts. Okay? So I'm going to find the slope first. So the slope is going to be B minus A. Oops, sorry. Minus A, which is the opposite of B over A. Okay? And then from here, we're going to write the equation of the line. Point slope form is preferential. If you're less comfortable with that and more comfortable with slope intercept, you can use slope intercept here, but I really, really, really encourage you to start shifting to point slope form. It's going to show up a lot more this year, and actually it's better than the other forms because it's the only form where you don't have to do any computation after finding your slope and your point. With slope intercept form, you plug in your m and you plug in your x and y, you still have to solve for b. So there's a potential takes more time. And then with standard form, same thing. You plug in your x and y, you plug in your slope, you still have to solve for c. So point slope is the way to go. Okay, that's what I'm going to use here. I'm going to come over here. Y minus, and it doesn't matter which point we use. I'm going to use the first one, but we get the same thing either way. So y minus 0 equals negative b over a times x minus a. And now I'm just going to rearrange this to get it to match this one. Okay. So y minus 0 doesn't matter. I'm going to multiply the entire equation by a to get that out of the denominator. So a is equal to, and I'm also, so this is this, I'm going to go ahead and distribute that negative b x instead of 1 over. So negative bx plus. Okay. Now I want the x and the y terms on the same side, and it looks like I divided by the total difference because I have 1 in front of x and y. So I'm going to move the bx to this side. So ay x term bx plus ay equals a. And now I want a 1 on the right side, and again we're going to divide by the coefficient. I'm going to divide the entire equation by AB and end up with, so the b's cancel out on the first term, so we have x over a, and here the a's cancel out, so we have y over b. Okay, and then we're just showing that the equation is 1. here can be written in that form. Okay. 9. Actually, the next 3 problems here are using what's called coordinate geometry. I know it's been a while since you've done that, but the idea is when we take a figure from geometry and we put it on a coordinate plane, then we can use some algebraic formulas like slope formula, distance formula, midpoint formula, etc., to draw conclusions about the figure. You know, if I just have a quadrilateral that's just drawn randomly on a blank page, then I don't necessarily know that it's a parallelogram or something without getting out like a ruler and measuring things, and we don't want to do all that. So the idea of these is that we put the points on the coordinate plane and then use the ordered pairs and algebra formulas to draw conclusions. Okay, so for this one right here, we have 4 points, and it says that they are corners of a square. We are looking for the inscribed and circumscribed circles. Okay, so let's go ahead and graph those. So 2, 3. I'm going to try and make it draw to scale, but if it's not the worst thing in the world. 6, 3. There. So that it's parallel to the axes. Okay. And then we are looking for the equations of the inscribed and circumscribed circles. Okay. Inscribed means that the circle is going to be completely contained in the square, and it's going to be tangent to the square at the midpoints of the 4 sides. Let's go ahead and find the center of the circle first. That'll help us draw both of the center of both circles. It'll help us draw the circles, and it's the center of the square as well. So I'm going to find the midpoint of one of the diagonals, and that will be my, that's not very straight, but that will be the center of my circle. There are a couple ways to do this. You could find the intersections of the midpoints, or I'm sorry, of the section or the diagonals. We could find, halfway between here, halfway between here. It doesn't really matter, but what we need to get to is the midpoint of, or the center of the circle and of the square. Okay, so because that will be the midpoint of this diagonal, I'm going to find the midpoint of segment AC. So halfway between 2 and 6 is 4. So I'm going to call this O. So O is at 4. And then halfway between 3 and -1 is +1. So O, the center of both circles, is at 4, 1. Okay. And if you think you have an idea where to go from here, go ahead and stop the video and, or at any point, stop the video and try it. But I'll go ahead and keep going. So get rid of some of these little extra marks. Okay, so my inscribed circle is going to be tangent at each of the midpoints. That's kind of circular. At each of the midpoints of the 4 sides. Remember, the things that we need to write the equation of a circle are the center and the length of the radius. So I know my center is at 4, 1, and then the length of my radius is the distance from here to any of these 4 points. I can use distance formula or something like that, but really, since these are all horizontal and vertical lines, I'm just going to count. So from the point to, this has an x coordinate of 2. A and D both have x coordinates of 2. This has an x coordinate of 4, so that means the radius is 2. Okay, so I'm going to write the equation of my inscribed circle as the circle with the center of 2. X minus 1 squared plus y minus 4 squared equals which is 4. And the circumscribed, the same center, but circumscribed means that now it is going to, the circle will pass through the vertices. If you ever draw figures by circles, start with the circle and then go to the inside. Okay. I'm doing the distance between the point 4,1 and the point 2,3. When you do distance formula, if you think about the fact that it's really just the Pythagorean theorem, instead of worrying about a formula like what number gets subtracted from what number, and then I've got a negative, and negative squared is positive, all of that, ask yourself these questions when you do it. It's actually a lot faster to get through the process of the distance formula with more mental math, and it tends to make a little more sense to us as well. So when I do the distance formula, I'm trying to find this radius. Okay, I do have a square root, but I'm not going to worry about like formulas or anything. I'm just going to say how far apart are the x's. So the 4 and 2 are 2 units away. So 2 squared is, 2 squared is 4. And then how far apart are the y's? Well, 1 and 3 are also 2 units apart, so that squared is also 4. So we've got the square root of 8 as our radius. Yes, root 8 can be simplified to 2 root 2. I don't need to do that, though, because I know that the very next step is going to be writing the equation of the circle, and part of the circle has r squared in it, so I'm going to square that, and it's going to be an 8 anyway. Okay, so for my circumscribed circle formula, x minus 4 squared plus y minus 1 squared equals root 8 squared, which is 8. Those are the two equations. Okay. Next one, show that the midpoint of the hypotenuse of any right triangle is equidistant from the 3 vertices. Equidistant means same vertices. We are dealing with a right triangle, so we're going to use coordinate geometry again, and we're going to put a right triangle on the graph in a way that makes it convenient to find measurements like distance, slope, etc. So since it's a right triangle, I'm going to put the right angle at the origin, and then the two legs of the triangle will be on the x and y axis. Okay, so add that. It could be isosceles, but not necessarily. So this way, we're assuming that two legs are the same length. Okay, so we've got a right angle here. This point is the origin, so 0, 0. Now, this point, obviously not a 0. If we want this to represent any possible right triangle, so this distance I'm just going to label A. Oh, actually, no, I'm not. I am going to label the variable, but thinking ahead, because I want a midpoint, I know that my formula for midpoint is dividing by 2. In other words, I want to find a halfway point between. So I'm going to, instead of labeling this as A, 0, I'm going to label it as 2A. That way, when I find the midpoint of the hypotenuse, I don't have any fractions. It would work if I used A0, then I would just have the x coordinates of the midpoint, but I'm just trying to make my computations a little bit easier. I have to deal with fractions. Okay, so I'm going to call this point 0, and then this one, I'll call this side, this leg, I'll label it B, so 0, B. Okay, so then my midpoint is halfway between those 2 points. The midpoint formula is average of the x's, average of the y's. Well, halfway between 0 and 2a is halfway between 2 is b. Okay, so now what I want to show is that this point right here, we'll call it m for midpoint, is equidistant from the 3 vertices. So I'm going to do the distance formula from m to each of those. I can leave. Okay, and again, if you want to pause it, try it on your own, you're welcome to do so. Okay, so the distance M, A, how far are the x's? Just A. How far are the b's? Just B. So the distance, the length of this segment is b squared. I'm not simplify that now, but that's okay as long as that matches what I get for the other two lengths. Okay. And B, from here to here, so how far are the x coordinates? A is how far are the y coordinates, so minus b. Same thing. And then lastly, and to c's, we've got how far apart are 2a and a, they're a units apart. how far apart are B and 0? They are B units apart, and all three of these are equivalent. Therefore, the midpoint is equivalent. For this last one, show that the line segments midpoints of sides lateral form a parallelogram. Okay, so again, I'm going to put this on a coordinate grid. I will have to use more than just A and B because we want to use any quadrilateral, but I am going to try and get as many zeros as possible because you're and as not necessarily as many. I want to have as few variables as possible. Okay, so make a quadrilateral here, and I am going to put one point, one vertex at the origin, and I'm going to put another vertex on the x-axis. Let's use I am doing 2 because I'm midpoint I'm cutting half ends this way. Okay, and then I do another point there. And I do need to make sure that my quadrilateral is not already a special type of quadrilateral, like a square, rhombus, or parallelogram, or trapezoid, because we're trying to show that this is true for any quadrilateral. Okay? So I can't have two sides that are the same. 2A0, I'm going to make this 2B, 2B, and this is going to be 2E. Okay, and unfortunately I do have 5 variables, but we still should be able to get a parallel. Okay. So I'm going to draw in the midpoints. And we'll call those ABCD for lack of creativity. Halfway between W and X, so that's my point. Halfway between 2A, comma 0, and 2B, comma 2C. 2A plus 2B all divided by 2 just gives me A plus B, and then 2C plus 0 divided by 2 is C. So again, our fractions. C is B plus D. Okay. Okay, so then what we want to show then is that ABC is a parallelogram. Definition of parallelogram is of parallel sides. So the formula, we also have theorems about parallelograms that say that opposite sides are congruent. So we can use the distance formula and show that AD and BC are the same length. Or we could find angles, but I don't think we're going to mess with tricks. I'm going to just use the definition here. You have options, but I'm going to use the definition and the opposite sides are parallel. Okay, so we find the slope of sides. So the slope of AB goes from here to here. So A plus B minus A is B. Minus 0 is C. And the slope of the opposite side, CD, is plus E minus E. Oh, back up. Hold on. It's slope wrong. Okay. Right overrun. Try that again. 0 is C. A plus B minus A is B. And then the slope of CD plus E minus E. So plus D minus E is B. And so this means that the plus b minus a plus b is. So then the b's cancel out and we get b minus a, right? So the last side, which is a d, is going to be b minus 0 over d minus a, which is the same thing. A b is parallel to BC, therefore it's a parallelogram. Okay. All right, hopefully that's helpful. If you still have questions on any of these, I'm happy to answer those for you. And there are some questions that use like midpoint or slope or perpendicular, like those kinds of theorems. There aren't any that are you creating your own coordinate geometry, like putting your figure on here, labeling your own points, that kind of thing. There's nothing where you have to prove. We still want to be able to do this, but don't stress out if you don't know how to do it before the quiz tomorrow. We can answer those questions afterwards, okay? All right, hope that helps.